The SureServo2 system gives you two ways to quickly stop the motor. You can use a single digital input to tell the drive to override its motor control and ramp down the motor, which would be appropriate for your home shop or other applications that don't need to adhere to stringent safety requirements. Think of it as a poor man's quick and dirty but non-compliant ESTOP button. Or you can use the SureServo2's built-in STO, or Safe Torque Off function, which is for fully compliant safety systems. The key thing to know about the SureServo2's STO function is that it instantly removes power from the motor, which means the motor will be left to free spin down on its own. There's a separate video covering the STO function, so we're just going to cover the motor override function in this video, which is ideal for a quick, simple, and inexpensive way to quickly shut down the motor in a controlled fashion. Let's do an example. This is the exact same hardware we used in the Quick Start video, so I'm not going to go into any detail about that here. But it's important to recognize that the STO jumper that comes with the drive is installed to bypass STO. That ensures that STO can't get in the way of our override demo. I did add a heavy pulley to give us more inertia. The quick thing to remember is digital input 8 defaults to the override function, and it expects a normally closed switch. If you want to assign it to a different digital input, then change digital input 8 to something else and assign the motor override code to a new digital input. I did a factory reset, switch to speed mode, and power cycle the drive. Now I can't emphasize that enough. You really do need to power cycle the drive after a mode change. If you can't get things to work after a mode change, yeah, it's usually because you forgot to do that power cycle. I'll enable the servo and turn up the potentiometer to get the motor spinning. If I hit the motor override button, sure enough, we get the motor override alarm code and the motor quickly stops. It stopped quickly because by default, the drive's built-in dynamic braking is enabled. There's a whole video dedicated to explaining how dynamic braking works, so we won't go into that here. Just know that it's enabled by default when the motor override button is pressed, and that it's a very efficient way to ramp the motor down quickly without generating overvoltage faults. When you release the motor override, the fault indication goes away and the motor starts right back up. Let's go to parameter 1.032 and change it to a 10 to tell the drive to let the motor free spin to a stop. This time when we hit the motor override button, the motor takes a much longer time while it free spins down. Now I'm using speed mode here, but this motor override will work for all drive modes. The problem with this simple motor override is, what happens if the motor override switch gets a welded contact and it won't open? Well, you can punch that button all day long, but your machine won't stop when you most need it to. Or what if the switch gets stuck open or it isn't wired correctly? There's all kinds of things that can go wrong that can prevent a simple motor override like this from working, and in many applications where the ESTOP has to work or bad things happen, you can't afford to take that risk. So what do? Well, you build a proper redundant ESTOP safety circuit that constantly tests itself and lets you know when something isn't right. The good news is the SureServo2 drive has the required circuitry built in, so it's super easy to do. Check out this video to learn how to set that up using the built-in STO function. Meanwhile, click here to learn more about the SureServo2 system and where to find more videos. Click here to subscribe to our YouTube channel so you'll be notified when we publish new videos like this, and click here to learn about Automation Direct's free award-winning support options.